Hello, today we will talk about clustering. What is clustering? In nature, we like to put the same thing together. So when we put them together, we will let them with some special feature and put them together. You just create the same things. What's called the same? You can see the same type. For example, the same color. For example, for the same height, the same weight. So we just according some special feature, and we just put them together. So it's called clustering. Just collect a lot of things. So clustering is the one data mining, one special way for data mining, and it's when we observe the data, and we just want to know before we have any things to label this method, we just according their features and put them together. So it's just the data to say I want to be put them together. So it's just a special way, and they know we want to put them together. So it's also a static data analyzer, just to create the things together. So it can be application to many areas. For example, the pattern recognition, you can just see a lot of things. For example, we can see the transmission packets on the internet. We can see a lot of image. You can put this together, or video surveillance. Also, we can see those things are special, and also we can use in the information retrieval to fetch some special methods from the text mining or from the test, or some bioinformatics we can use to analyze the medical data. Also, a lot of things. So, how we do that? So, just we use the spatial algorithm to do that? No, it's just a simple idea. These two things are close, very similar. We can put them together. Just this idea. So there's a lot of clustering algorithm can be used, but Infamous, so this came in as a hierarchical clustering. So if you found something interesting, but most of them are not so interesting, maybe nonsense even. So you can see some things. For example, we can test them. We have to verify all of them. These things maybe with some label, you can see something very specific. Maybe something you put it together with the label, you can see a lot of interesting things. But most of the time, you cannot understand why. For example, in the US, the Walmart have do a one-time data mining. He found something, beers and diabetes, and are easily to buy at a Friday night. Why? Because of the Super Bowl. And people, for example, the male to buy some beer for the Super Bowl, and his wife may told him, I usually buy some that for me. So these two things are put together. But if you don't know the reason, you will not understand why. You will see these two things are nonsense. You can understand why, but you analyze it, you will know. So it's kind of data oriented, and we have to evaluate. So this will use two things for the internal evaluator and the external evaluator. Internal evaluator is the things we just verify the cluster is okay or not, and this things is much better than external because you can see the group, the elements in the group are different to other elements in our group. So you have to verify the score. And how do we use that score? We can use the similarity to verify that. How we describe the similarity between group? We use three, maybe more ways. For example, the distance. For example, the cosine value, and a lot of things we can measure that. For example, and you can imagine, you can put in a spatial domain. We can check that length is the same or not, maybe. So a lot of things we can do. So first is the distance. What's the distance? Distance is the spatial way to verify these two things. Is the same or not? Because if you see the 2 points, these 2 points are different. There are some lengths between them. So if the lengths of these 2 points are 0, maybe these two things are the same. So we can use the distance. We can put the things into a spatial domain, spatial space. We can imagine, or we can measure the distance. The most easy way is use the geometry distance. I use that formula. We can see the distance between 2 points, and also we can use the Euclidean space. You can use those things. It's another way to measure the distance. And also, we can use the cosine value. We can use that to treat all the things to a spatial vector space. Each point connect to 0 point. We can form a spatial vector. And we use these two vectors to calculate the distance, the cosine value. So we can try to find the angle. If the angle is 0, maybe these two things are similar. So we can use the cosine value. We can use the function over there at the bottom. If these two vectors we want to calculate is cosine value, we can see the v1 dot v2, these two values. Two vector, we can use the dot and divided by the length of these two vectors. And we can see the cosine value. If the cosine value is 0, then these two vectors are the same way. Just the time, maybe one is several times of the other one. And if these two are maybe 1, maybe 1 is close, maybe 0 is different way. I mean, these two things are nothing between these two vectors, because it's different way. So you can see the cosine value to check these two vectors, these two things are similar or not. This is the way we evaluate the cosine value. So use these two things, we can calculate the similarity. The similarity is to measure these two spatial things are the same or not. We can use distance. We can use, for example, we throw it into a spatial space. We can calculate this point, the distance, and the vectors. And we want to, for example, we can use the string. We want to verify these two strings is similar or not. We can put them into a spatial word space, and this word may be 3-dimensional. It can only contain the three assets. For example, the first one is hello, and the other one is word, and the third one is John. And we can transform them to a spatial vector for these two, or maybe we can transform them to a spatial points, and we can calculate the length, the distance between these 2 points. Maybe we also can calculate the cosine value. We can see the similarity. And this one is how we evaluate the internal cluster. If the clustering between different groups are much larger, and the distance within the group is very, very small, and this one will be higher. So if these two things, if this value is very high, and we can see the clustering results very good. If this one is very, very low, then this nothing. So this one is how we evaluate the clustering. We have clustered all the things. We put these two things. We form the two clusters. Is okay or not? So the dB index is very high, and this means these two things are close, and it may be these two clusters not good. So it's how we evaluate the clustering.